String theory is a widely circulated physical theory, but what might surprise you is, it is actually not a theory at all. It is merely a conjecture by physicists. In the field of popular science, we often hear the word theory. However, it is often misused. Many of the theories you've heard are actually hypotheses. There is a very important distinction between theories and hypotheses. There is a significant difference. A hypothesis is merely a conjecture with some basis. They often represent the best answers we could come up with at the time, but it is still just a conjecture. These hypotheses are either untested or cannot be tested. The thought experiments we often hear about are actually just conjectures as well. For example, you have definitely heard of the holographic universe theory and the virtual universe theory. According to these theories, our entire universe is either a holographic image or a computer simulation program. Although the names of these theories sound cool, but they are not theories. They are merely a thought experiment. Cosmic strings similarly, even widely circulated theories like string theory. In fact, it is not a theory either. It is more like a hypothetical model of the universe. However, a theory is a more scientific guess than the thought experiment we just mentioned. A more scientific guess. But since it is extremely difficult to test, and there are very few experimental results related to string theory, therefore, it does not actually reach the level of a theory. To become a theory, it must withstand testing and be supported by a large amount of experimental results. Generally speaking, a hypothesis is used to make predictions, and experiments are meant to validate these predictions. If the predictions do not match the experimental results, then either the experiment has gone wrong, or the hypothesis needs to be revised. But if a hypothesis can consistently make accurate predictions, then it can eventually be upgraded to a theory. A hypothesis must overcome numerous challenges to become a theory. It needs to pass through many hurdles. It not only needs to be validated through experiments, it must also withstand criticism from peers. Furthermore, peer scientists will specifically design experiments aimed at disproving this hypothesis. If this hypothesis still holds in these experiments, eventually scientists will reach a consensus. This hypothesis will become a theory. Einstein's theory of relativity went through these numerous challenges and ultimately became a theory. Most predictions of relativity have been confirmed. However, even if a hypothesis upgrades to a theory, this does not mean it is truth. A theory is merely used to explain our experimental and observational results. But the theory itself is not truth. No matter how perfect this theory is, it is subject to change. In the past 100 years, general relativity has been regarded as an unshakable law of the universe. Yet it is, in fact, incomplete. We are stepping into an era where general relativity is about to be modified, or even completely overturned. Therefore, whenever you hear science communicators talk about dark matter, dark energy or other controversial theories, please remember that these theories are actually just hypotheses.